Now we have a new topic, that means K-map. We all know that we have simplified the Boolean function using Boolean theorems, and it is a time consuming process, and we have to rewrite the simplified expression after each steps. To overcome this difficulty, Karnaugh introduced a method for simplification of Boolean function in an easy way, and this method is known as K-map. Now, uh, K-map is a simple graphical method which consists of 2 to the power n cells for n variables. That means the adjacent cell are differ only in a single position. As I told you that the K-map is used to minimize the Boolean functions which have 2 to 5 variables. That means, for example, if we take a two variable K-map, then the number of cells in that particular K-map will be 2 to the power 2, that means 4. The output which we get through K-map can be either in the form of sum of pos or sum of product of sum, that means sum sop and pos. Now this is the example for two variable K-map. uh, this the total number of cells are 2 to the power 2, that means 4. Here each cell are unique identities, that means M0, M1, M2 and M3. Clear? For minimizing the function, we have to create the groups of cells with the adjacent cells for minimization. And the possible groups is, especially for this for this example are M0, M1. That means we have to group only M0 with M1, M2 to M3, M0 to M2 or M1 to M3. We cannot make the group of M0 and M3 that and or M1 and M2. That means diagonally. We cannot create the diagonal grouping. Now this is the example for the three variable K map. Here total number of cells are 2 to the power 3. That means total 8. Here each cell has unique identities, that means from M0 to M7. And these are the unique identities for each cell, that means M0, M1, M2, M3, M4, M5, M6 and M7. These this is the M0, that means in the suffix number 0, 1, 2, 3, 4, 5, 6, 7 represent the binary equivalent of that particular identity, that means 0, 0, 0. For this cell the identity will be 0, 0, 0, that means 1, 0. For this particular cell the identity will be 1, 0, 1, that means this is 5. 1, 0, 1, that means this is the 5. Now for this cell, this is M6, that means 1, 1, 0. From this 1 and from this part we get 1, 0, that means this is 1, 1, 0, that means this is equal to 6. That's why this the identity of this particular cell will be M6. Now this is the example for 4 variable, that means obviously here we have a 4 variable, that means the total number of cells will be 2 to the power 4, that means 16. And the identity is from 0 to 15. Now for 4 variable K-map the possible groups are 16 cells. Okay, now the groups 16, 8, 4, 2 and 1. The condition of the one cell group is only possible if cell unable to group with his adjacent cell. On Should always remember that the group must be made as large as possible. That means if we have a 8 cell group, we cannot create the two 4 groups. Clear? That means we have to create the largest the group, which is possible. Now this is the 5 variable k map. We have to create the two cells of 4 cross 4. That means 4 variable for this and 4 variable for that. But here are we have 5 variable. That means v, w, x, y and z. And this k map represent for the v is equal to 0, and this k map correspond to the v is equal to 1. Obviously, if v is equal to 0, then the 5 variable k map become the 4 variable k map. So if we have function for 5 variable or more, then we can't use the k map method. Instead of k map, we use another method for minimization, and this method is known as tabular method. But this method is not the part of your syllabus. For this, the but I will discuss this tabular method in the last when whole syllabus is over, just for your knowledge. Okay. Now this side simple represent the k map for the two variable, 3 variable and 4 variable k map. In that particular in a particular 2 variable k map, we have 2 to the power 2, that means 4 cells, and these are and identities of these particular cells are 0, 1, 2 and 3. Now if we have 3 variable, this will be our k map for 3 variable. Here a, b, c, we have 3 variable, and the identities of these variables are these cells are 0, 1, this is 2, and this is for 3, 4, 5, and this one is 6, and this is 7. Now as I told, there should be a single bit difference between the identity of two adjacent cells. In this slide, these are the unique identities of the cell with respect to 2 variable, 3 variable and 4 variable. Now if we take the example for 4 variable, we have total 16 cells, and the identities of these cells are 0, 1, this one is 2 and 3, 4, 5, 6, 7, this one is 8, 9, 10, 11, 12, 13, 14, and last one is 15. As I told you that there should be a single bit difference between the identities of the two adjacent cells. If we take this example, that means 13, that means 13 will be equal to 1, 1, 0, 1. This is our 13. Now this is our 15, 1, 1, 1, 1. If we compare these two numbers, these two binary number, there is only one bit difference. That means in that particular bit, that means this 0 become 1, and rest bits are same. If uh, if we take the 13 and the adjacent cell will be 14, that means 1, 1, 0, 1, and the 14 will be 1, 1, 1, 0. Now if we compare these two numbers, we see that there are 2-bit difference. That means this 0 change become 1 and this 1 becomes 0. That means we have 2-bit difference in that particular two cells. That's why in tabular method, in a K map, each cell have a unique identities and each adjacent cell will differ each other by the single bit, and this will be the main rule for the K map. Now come to the next topic, and this is the various implicants in the K map. Implicant basically group of ones or any single logic state one can be combined with the K map for a function represent a term. That means in a particular given binary function or Boolean function, each term of that particular function and each mean term or max term of that particular term is known as its implicant. Clear? And a prime implicant of the logical function is a term that cannot be combined with the another term of to eliminate a variable. The a single one represent a prime implicant if there is no other one neighboring it. Two neighboring ones represent a prime implicant if they cannot be contain a group of four ones. That means in that particular example we have three prime implicant. That means this one and this one. That means simple, we have to create the groups in the K map to the adjacent cell. That means this cell can be grouped with the this, and this cell can be grouped with this neighboring cell, this, and this cell can be grouped with this particular cell to adjacent cell. Now we have three groups, that means 1, 2 and 3. First group, second group and third group, and these three groups are known as prime implicants. The objective of minimizing a logical function is to determine the smallest number of prime implicants that together cover all the mean terms for the given function. That means uh, if we find the prime implicant, that means the main objective of that particular for finding the prime implicant is the to minimize our function. Clear? Now second implicant is known as essential prime implicant. The prime implicant is said to be essential if the only one to cover or more mean terms. The minimized form of logical function contains all the essential prime implicants. That means here are two essential prime implicants. But this prime implicant is not the essential because the all the member of that particular group involved with the other groups. That means the member of that particular group involved with first and second group. That's why this will not our essential prime implicants. Obviously the minimized function of our particular function is the sum of or product of these essential prime implicants. That means this prime implicant will not the part of our minimized function. Clear? Redundant prime implicant, that means obviously this group is known as redundant prime implicant. This type of known as clear. Obvious. This type of prime implicant is also known as dummy group, and these group are not the part of the simplified function, as I told you before. Now, we take some. Now we can understand these implicants, prime implicants, essential prime implicants, and redundant prime implicants with the help of some example. And these are some example. Here, a function f is equal to sigma 1 5 6 7 11 12 13 4 13 and 15. That means these are the main terms which are associated with this function. That means for these main terms this function will be high, and in that particular example we have to find the number of implicants, prime implicant, essential prime implicant, and redundant prime implicants, and fourth one is a selective prime implicants. I will discuss this selective prime implicant in that particular example. Here, simple, the maximum identity of that of the mean terms will be in that particular function is 15. That means 15 basically, if we convert this 15 into binary, we have 111. That means we have 4-bit number. That means this particular function have 4 variables. Clear? That's why we create a 4 cross 4. That means 4 variable came as, that means total 16 cells here. Now simple, we fill these mean terms, these given mean terms into the K map according to their identities. That means this is for 0, this is for 1, this is for 2, this is for 3, this is 4 5 6 7 8 9 10 11 12 13 14, and this one last one is 15. Okay, and we fill these values. That means 1, that means we fill 1 at cell 1. 5, that means we will fill 1 at cell number 5. 6, we fill 1 at the address of 6. 7, this one is the 7th position of the identity of that particular cell is 7. This one is 8, no sorry, 11, this is 12, 13, and this one is 50. Okay, now we grouped. Now we create the group for these binary number, and that means we create this group 1, this group 2, this group 3, and this group 4, and last one is this is also a, this can also our a group 111. That means total 4. Now we have total 5 groups, and these 5 groups are our prime implicants. Okay, and obviously we have 8 mean terms that are associated with this function. That means the total implicants will be 8, and after grouping we have prime implicants, and these are 5 implicants. Now we calculate the essential prime implicants. Firstly, we have to create a redundant prime implicant, that means dummy group. And obviously, as we see in that particular group, here are 4 members, and all 4 members are associated with other groups. That means the member of that particular prime implicant, that means group number 5, all members of that particular group are associated with different groups. That means this group become our dummy group, and obviously this group will not the part of our function. Okay, now obviously if we identify our redundant prime implicant is the number of 5, fifth number group. So we have total prime implicants are 5, and we have one redundant prime implicant. That means rest rest prime implicants are our essential prime implicant. That means these are 1, 2, 3, and 4 are our essential prime implicants. Clear? Now we take some other example. This one. Here are total 1, 2, 3, 4, 5, 6, 7. That means we have 7 implicants, and we fill these mean terms according to their cell identities in the K-map, and obviously the maximum mean term exists in that particular function is 15. That means this function have total 4 variable. That's why we create here a 4 variable K-map. That means total 16. Now we create the prime implicants, and these prime implicants are simply we create the grouping of that particular given mean terms. This one. Clear? That means total 6 prime implicants. That means total 6 groups are there. Now here we have to find the redundant prime implicant. That means obviously these are our redundant prime implicant. That means the group of that the member of that particular group will associate with other groups, and this one have associated with this group and this group. That means we have 2 redundant. Now total we have a essential prime implicant. That means total 6 minus 2 will become 4. But in that particular example, if we take this group, this group, and this group, and this group, that means we have total 4 essential prime implicants. But if we take that particular grouping, this can be possible. That's why we can say that we have 4 selective prime implicants, and these prime selective prime implicant will over the part of our minimized function. Clear? Now after that uh, we take some example here for these if we have a k-map of four variable like this, we have total 16 variable, 16 cells of the variable a b c d. Suppose if we have a function f and the mean terms of that particular function are these are the mean terms of that particular function. Suppose this one. Now we have to create the groups. We can create the groups like that. That means this one, this one, this one, and this one. We can create the groups only in the order of 2 to the power n. That means n will be 0, 1, can be 0, 1, 2, 3, 4, and this the number of the value of the n is totally depend on the number of variables. That means if we have four variable, that means n cannot be greater than 4. That means if we create a group in a four variable k map, that means we can create the group of 1, that means 2 to the power 0, 2 to the power 1, that means 2. That means we can create the group of two mean terms or two adjacent cells. 2 to the power 2, that means 4. We can create the group of 4 adjacent cell. 2 to the power 3, that means 8. We can create the 8 we can create the 8 adjacent cell. We can create the group of 8 adjacent cell, or 2 to the power 4, that means total 16. That means we can create a whole group of 16 cells. Clear? That's why we are creating here the total 4 members, 4 cells. That means we create here of 4 variable. Now according to this, we have total 4 4 prime implicants. That means for this one, this one, this one, and this one. Clear? Now in now we take this second example. Suppose we have another 4 variable function. That means we have to create the 4 variable function, 4 variable k map. That means 1 1 1. Suppose this one, this is our k map of 4 variable a b c d. Now we can create the group like that. That means this grouping, this type of grouping is called known as folding grouping. We will discuss it, the types of grouping. We will discuss the type of grouping in the next lecture. Now we have to, now we can create this group, we can create this group, and we can create also this group. Clear? Here total groups are one folding, one folded corner folding, and one is this, that 1 2 3 and 4. That means here total prime implicants will be 4 in that particular example. Clear? Now if we take, if we see this group, and this group have 4 variable, and these four variables are associated with the other group also. That means this one and this one is associated with the corner grouping, and these two ones associated with this square grouping. That means the two all the group of that particular cell group is involved with the other groups. That means this group become our redundant prime implicant. That means in that particular example we have total 4 prime implicant, from which we have only one redundant prime implicant. That means essential prime implicant will be 3. That means this one and the folding one. Clear? Now take another example. Suppose we have a function f is equal to sigma 1, 3, 5, 7, 8, 10, 12, 13, and last one is 14. Now we fill these meantime values in a 4 by 4 k map, and obviously we can see that the in that particular example we can see that the highest meantime is 14. That means we have to create this 14 with the help of 4-bit number. That means that's why this function have 4-bit 4 variable. That's why we create here a 4-bit k map, 4 variable k map, and the filling of that particular example will be this one, and the grouping of that particular k map will be like this, and this one can be grouped with this one, and this one can with with this one. That means this one can be associated with that particular one and can be associated with that particular one. That means the function of that particular the output of that particular function, that means the total prime implicants will be 1, 2, 3, 4, and 5. That means total prime implicants are 5, but the essential prime implicants are only 1, 2, prime implicants are 1, 2, and 3, 4. 1, 2, 3, and 4. But essential prime implicants are 1, 2, and either this or either this. That means total 3. And that means if we take this group as an essential prime implicant, that means this group become your selective prime implicant, and this is totally depend on the user. Clear? That means the output of that particular function will be a bar d plus a d bar plus a b c bar, or if we take this group as a essential prime implicant, if we take this group as a essential prime implicant, and this the function will be a bar d plus a d bar plus b c bar d. Both function are correct, and this selection totally depend on the user. Clear? Now uh, that's all from this lecture. In the next lecture we will discuss about the group types of groupings in the K-map, and how we simplify our function using K-map. Thank you.